Declassified. I'm Nathaniel Shepard, your host on behalf of author Daniel P. Douglas. In this series, we reveal real Cold War secrets and excavate the classified details your government hoped you'd never discover. And here we go. The Insectothopter and Charlie. When the CIA built robot creatures, the spy agency's decades-long quest to turn animals into surveillance machines. It was 1970, and in a workshop somewhere in Langley, Virginia, a watchmaker bent over his workbench. He wasn't fixing timepieces. He was building a dragonfly. Not just any dragonfly, but a mechanical insect that could fly, hover, and carry a listening device into places humans couldn't go. The CIA called it the Insectothopter, and it represented everything brilliant and absurd about Cold War espionage. 20 years later, in another CIA laboratory, engineers were waterproofing a robotic catfish. They named it Charlie, because of course they did. These weren't Hollywood props or science fiction fantasies. These were actual projects funded by actual tax dollars, built by actual scientists who genuinely believed that the future of espionage involved mechanical dragonflies and robot fish. The fact that both failed spectacularly didn't stop the CIA from trying. It never does. Welcome to the world where America's premier intelligence agency decided that nature's creatures made perfect spies if only they could be improved with a little engineering. The problem that needed tiny solutions. By 1970, the CIA had a listening problem. Not the kind where they couldn't hear things. The kind where they had developed incredibly sophisticated miniature listening devices, but no way to get them where they needed to be. You couldn't exactly walk into a Soviet embassy and plant a bug. You couldn't throw one through a window. You needed something subtle, something that wouldn't raise suspicion, something that could fly or swim right past security. The CIA's Office of Research and Development looked at this problem and came to a logical conclusion. They would build robot animals, tiny, sophisticated, remote-controlled creatures that could infiltrate any location. It was brilliant. It was innovative. It was completely doomed to fail, but they wouldn't figure that out for years. The program began with a simple question from the Office of Research and Development. Could they create a delivery system for their miniature listening devices that would be completely undetectable? The answer, they decided, was biomimicry. Copy nature. Build machines that looked and moved like real creatures. After all, who would suspect a dragonfly of being a spy? The Insectothopter. Death from above. 1 gram at a time. The first attempt was going to be a mechanical bumblebee. CIA scientists spent months studying bumblebee flight patterns, wing movements, and aerodynamics. Then they built a prototype and watched it crash right away. Bumblebees, it turned out, flew in ways that violated everything engineers understood about flight. Their wings were too small, their bodies too heavy, their flight patterns completely erratic. As one CIA document noted with masterful understatement, the bumblebee design showed much too high wing beat frequency, and the stability, guidance, and control seemed impossible. Then, an amateur entomologist on the project suggested a dragonfly. Dragonflies were perfect. They could hover, fly backward, turn on a dime. They existed on every continent except Antarctica. Most importantly, they flew in ways that engineers could actually understand and replicate. The CIA contracted a watchmaker to build the prototype. Think about that for a moment. The same skills used to build intricate timepieces were now being applied to build a spy drone. The watchmaker created a mechanical dragonfly that was a marvel of 1970s miniaturization. It measured just 6 centimeters long with a 9-centimeter wingspan, perfectly matching a real dragonfly's dimensions. The technical marvel that couldn't handle a breeze. The Insectothopter was genuinely impressive for its time. It contained a miniature fluidic oscillator that moved the wings up and down at the proper frequency to generate both lift and thrust. A small amount of liquid propellant mixed with an oxidizer created gas to drive the oscillator. The excess gas vented out the rear for additional thrust. It was painted by hand to look exactly like a real dragonfly, complete with intricate wing patterns and segmented body. But the real innovation was the guidance system. Radio control was impossible because the extra weight of receivers and batteries would doom the tiny craft. Instead, CIA scientists developed a laser guidance system. An invisible infrared laser beam would heat a bimetallic strip in the dragonfly's tail, opening or closing valves to control thrust. Another laser acted as a rudder for steering. The same laser system would also serve as the data link for transmitting audio from the listening device. The Insectothopter could fly for 60 seconds and had an operational range of about 650 feet or 200 meters. In laboratory conditions, it worked perfectly. The tiny drone could take off, hover, maneuver, and land exactly where operators directed it. Then they took it outside. The first outdoor test revealed the fatal flaw. The slightest breeze, anything over 7 miles per hour, sent the 1-gram Insectothopter tumbling through the air like a leaf. The laser guidance system required an operator to manually keep the beam trained on the tiny drone during flight. In a wind tunnel, this was manageable. In the real world, with wind gusts, thermal currents, and unpredictable air patterns, it was impossible. As project engineer Charles Adkins reported, though the flight tests were impressive, control in any kind of crosswind proved too difficult. The Insectothopter performed perfectly in the controlled environment of a laboratory, but failed completely in the chaos of the real world. The program cost $140,000, about $1 million in today's money. For that, the CIA got a mechanical dragonfly that could only fly indoors. After years of development and testing, the Insectothopter never flew a single operational mission. The project was quietly shelved, and the prototype was relegated to the CIA museum, where it still sits today. But failure didn't stop the CIA from trying to copy nature. If they couldn't conquer the air, maybe they could master the water. Enter Charlie the catfish. Fast forward to the 1990s. The Berlin Wall had fallen, the Soviet Union had collapsed, and the Cold War was officially over. But in the CIA's laboratories, the Cold War mentality lived on like a ghost that refused to die. The same paranoid innovation, the same willingness to throw money at improbable solutions, the same conviction that technology could solve any intelligence problem. The Office of Advanced Technologies and Programs decided to explore underwater surveillance. Once again, they turned to nature for inspiration. This time, the target was aquatic. The CIA wanted an unmanned underwater vehicle, UUV, that could secretly collect water samples near suspected nuclear or chemical facilities. The samples would reveal if radioactive materials or chemical weapons were being produced upstream. But how do you get close enough to collect samples without being detected? You build a robot fish. The CIA actually built 2 robotic catfish, naming them Charlie and Charlene. Because even top-secret spy fish need proper names. The robots were 61 centimeters long, about 2 feet, which made them respectably sized but not suspiciously large for catfish. The engineering of a fake fish. Charlie was more sophisticated than the Insectothopter in many ways. The robot's body contained a pressure hull to protect the electronics, a ballast system for depth control, and a communication system for receiving commands. The tail housed the propulsion system designed to mimic the swimming motion of a real fish. Unlike the Insectothopter's impossible laser guidance system, Charlie was controlled via a line-of-sight radio handset. An operator could direct the robot fish to swim to specific locations, collect water samples, and return. The CIA's own description of Charlie's capabilities included speed, endurance, maneuverability, depth control, navigational accuracy, autonomy, and radio communications. The idea was elegantly simple. Deploy Charlie into a river near a suspected weapons facility. The robot swims upstream, collects water samples, then returns to its handlers. Scientists analyze the samples for nuclear isotopes or chemical signatures. If they find evidence of weapons production, they know exactly where it's happening. Charlie could blend into any freshwater environment where catfish were common. Unlike the Insectothopter, which had to battle unpredictable air currents, Charlie operated in the relatively stable underwater environment. The robot fish seemed like it might actually work. The classified fish. Here's where the story gets frustrating. While we know the Insectothopter failed because of wind, we don't know what happened to Charlie. The CIA has acknowledged the robot catfish existed. They've released photos and basic specifications. They've even made a video showing Charlie swimming, and it's genuinely hard to tell it's not a real fish. But the operational history, classified. Did Charlie ever swim up a river in North Korea or Iran? Did the robot successfully collect water samples that revealed secret weapons programs? Did it get caught in a fishing net on its first mission? We don't know. The CIA isn't telling. What we do know is that Charlie represented a more mature approach to biomimetic espionage than the Insectothopter. The technology was more practical, the mission more achievable, the environment more forgiving. But the very fact that details remain classified suggests Charlie might have had at least some operational use, unlike its dragonfly predecessor, the legacy of mechanical creatures. Both the Insectothopter and Charlie represent a particular kind of institutional optimism that characterized Cold War intelligence work. The belief that any problem could be solved with enough money, enough engineering, and enough creativity. The conviction that if nature could do it, the CIA could do it better. The Insectothopter proved that sometimes nature's solutions are more complex than they appear. Dragonflies don't just fly, they constantly adjust to wind conditions using sensory feedback systems that no 1970s technology could replicate. They have millions of years of evolution optimizing their flight. The CIA had a watchmaker and a can-do attitude. Charlie showed more promise because fish swim in a more predictable environment than dragonflies fly. But even Charlie faced limitations. Line-of-sight control meant operators had to be relatively close. Radio signals don't travel well through water, and there's always the question of what happens when a real predator decides your robot looks tasty. The modern evolution. Today, both projects look quaint compared to modern drone technology. We have quadcopters the size of insects that can fly in wind, We have underwater drones that can operate autonomously for months. The technology that seemed impossible in the 1970s and challenging in the 1990s is now commercially available. But here's the thing. The CIA was trying to build these devices decades before the technology truly existed to make them work. They were pushing the boundaries of what was possible with analog controls, primitive batteries, and mechanical systems. They failed, but they failed in interesting ways. The Insectothopter influenced a generation of research into micro-aerial vehicles. Universities and defense contractors studied its successes and failures. The problems it encountered, from power to weight ratios to control in turbulent air, became the research questions that drove development of modern mini-drones. Charlie's descendants swim in oceans around the world. Modern biomimetic underwater vehicles use the same principles Charlie pioneered, but with better materials, better batteries, and better control systems. Some even look like fish, though most have abandoned disguise for efficiency. The verdict: the Insectothopter and Charlie represent the beautiful absurdity of Cold War intelligence work. Faced with the challenge of covert surveillance, the CIA's response was to build robot animals, not metaphorically, literally. They hired watchmakers to build mechanical dragonflies. They engineered fake fish with pressure hulls and ballast systems. These projects consumed millions of dollars and years of development. They employed some of America's brightest engineers and most creative thinkers. And in the end, they produced a dragonfly that couldn't fly outside and a catfish whose achievements remain mysteriously classified. But that's not really the point. The Insectothopter and Charlie weren't just about creating functional spy tools. They were about pushing boundaries, exploring possibilities, and refusing to accept that something was impossible just because it had never been done before. The CIA museum displays the Insectothopter prominently, and Charlie sits nearby, mechanical testimony to an era when America's spies genuinely believed they could improve on millions of years of evolution. They couldn't, of course. But the fact that they tried, that they built these remarkable little machines, that they got a mechanical dragonfly to fly at all, even if only indoors, says something profound about institutional ambition. In a world where we carry supercomputers in our pockets and fly drones from other continents, it's easy to mock these failures. But the Insectothopter and Charlie were attempting something that had never been done before. They were the Model T of spy drones, the Wright Flyer of robot fish. Primitive and limited but necessary steps on the path to something better. The next time you see a dragonfly hovering near a window or a catfish swimming in murky water, take a moment to wonder, is it real? Is it a robot? The answer is almost certainly that it's real. The CIA's robot creatures never made it past the prototype phase. But somewhere in Langley, in a classified vault, there might be documents describing Charlie's missions, successes we'll never know about, failures we'll never learn from. And somewhere else, engineers are probably working on the next generation of biomimetic spy creatures, having learned from the failures of the Insectothopter and whatever happened to Charlie. Because in the intelligence world, failure is just another word for needs more funding. And there it is. Another documented descent into the declassified, filed properly, stamped accordingly, and revealed at last. I'm Nathaniel Shepard, your host on behalf of author Daniel P. Douglas. Be sure to check out Daniel's Substack, The Intelligence Bulletin from author Daniel P. Douglas, for other podcast series, written articles, and links to all of his books. Thank you for listening.